Hi all, and welcome to another Generative Components tutorial. Today, I will be looking at some custom list nodes that we developed to help new users transition into Generative Components. I've made these nodes available for free, so you can use them in your next projects. Just check the link in the description. To start off, we're in a blank file based on the default design seed. The first step is to load the new list nodes. This is done by clicking on Model and then clicking on Add-ins. This opens a dialog where you can load custom add-ins. Clicking on the project add-ins will open a dialog to select an add-in you wish to load. In this case, I placed the list.dll in the workspace under Standards and Assemblies, which is the default location in my setup. To load, simply select the add-in and click Open. A dialog will appear showing the add-in was successfully loaded, and you will see it in the list. Like GNT files, add-ins have the option to be stored in the current file or in your GC environment. I have selected both because I would like to have the list nodes available in every file I'm using in this project. You will now see a new section called Lists in the Node Types window. This has 6 new nodes. They are List Filter by Bool, List Filter by Items, List Item, List Join, List Length, and List Split. To demonstrate the functionality of each node, I'll set up a quick list of circles. To start, I click on a point icon, which is my quick way of creating a base CS. I then drag in a point node and open up the function dialog box and drag in a series function. For this demonstration, I'll just set up the series from 0 to 10,000 in steps of 1,000. Linking this to the X translation of the point, we now have a list of points. I'll now drag in a circle node and place it by center and radius. I link the center points to the new points I just created, set the radius to 200, and for the support, I use the base CS XY plane. With this simple list set up, let's look at the new list nodes. Dragging in the first list, Filter by Bool, you can see it has 2 inputs. The first accepts some objects, or any type of node, and for this example we're going to use circles, but we could use arcs or curves. The second list is a list of bools, so this has to be a true and false list. This could be linked to a bool expression related to some size or length, or if the polygon is planar, but for this example, I will simply create a bool list using an expression node. The key is to have a bool list that is the same length or longer than the list you wish to filter. So I'll just copy the true and false a few times to make a list. Remember to include this list within some curly brackets on each end. So linking up the circles to the input and the bool list to an input, you now see, if you hover over the output, you can see the values have been sorted. To demonstrate this, let's link this to a simple solid node with an offset of say 2000. And now you can see the solids have been extruded based on our filtered list. The second list is Filter by Items. So dragging in that node, we can link the circle list to the input list. Filter items in this node can be a list of indices from the list. For example, we open curly brackets and we can input 0, 1, 2 and close curly brackets. And if we connect this to our solid node, you will see this list results. So changing the inputs will give you an option to target any number within the list. However, if you input a number that is greater than the input list, you'll receive an error. So in this case, if we change the number to 10 or above, it will error as the input list only has from 0 to 9, or 10 items. Changing the list back to 9, you'll see the node is now happy. This list could be a single item, it just needs to be inside curly brackets. The next list node is similar to the last example, however this one only accepts a single item. So in this item, we type in the number 6 and there's no need for curly brackets. This could be linked to a slider or other inputs to isolate the item you want from the list. So linking this to a solid node, you'll see a single item appear. The next list node is List Join. So let's first copy the point and circle nodes and generate a second list. I'll just change the Y value to 5000 so it is easy to see. Dragging in the List Join node, it is very simple just to link up the first list to input list 1 and the second list to input list 2, and they will be joined. Linking that to a solid node, you can now see you have a full list of solids. The next list node is a simple list length, so linking this to any list will just return its length, or the count of the list, so in this case 10. Linking 2 lists together will return the number 2, as it only counts the top level of the list. So removing the circle 2 list, the list length now returns to the joined list length of 20. The final node is the List Split node. The inputs for this node are an input list and an integer for the point at which you wish to split the list. For this example, we will link up circle 2 to the list input and we'll put index 4 as the split point. The output is 2 lists, one from 0 to 3 and the other from 4 to 9. If we link up a solid node to the node, it will return the first list. However, you can link it directly to list 1 or list 2 outputs. Adjusting the split point will adjust the results. So hopefully, you'll find the list nodes as useful as we have in your next projects. I encourage you to download the list nodes. If you have any questions or requests for further list nodes, leave them in the comments. Until next time, thanks for watching.